Hello, let's talk about the composite rectangle method. So let's assume we have a function f of x, of course a function of x. This means that the independent variable is x and the dependent variable is f of x, which is very important when we want to find an integral because it tells us towards which variable we integrate. So I have this function f of x from point A to point B. We know that the integral physically means the area under the curve that this function is forming. So I want to find this area I. So this is a numerical method, which means that it will give me an approximate answer, and a good first approximation of this integral is to break down this function into rectangles. So I start from point A and I have here x1, x2, all the way to point B. So I can approximate the integral as this little rectangle here and this little rectangle over here and this little rectangle here, and so on up until the very last rectangle on the right end. Obviously we can see that we either overestimate the area, like it happens in this rectangle here, or we underestimate the area as happens here. That's a good first approximation. Alright, so let's find this integral then. I will equal the area of all these rectangles we have under the curve. So let's take the area of the first rectangle. We know that this distance is always the same because we took the same step h everywhere. So the first rectangle is the area equal h times the height. This height, we know it because that's point x1, so height is f of x1. So I write here that the area of the first rectangle is h times f of x1. Now I move to the second rectangle. The base is h again, and the height is this point here, which of course is f of x2. And the next rectangle is again h times f of x3, and so on and so on and so on up until point B, where at B point we have the last rectangle, which has an area of h times fb. You can easily spot that there's a common multiplier here, which is the h. So the integral will equal h times the summation of fxi, starting from 1 and ending to b. So this is the rule of the composite rectangle method. We just need to pay attention that the first point on the left is not added. We did not multiply by h times f of a, because then this would add an extra area to my integral. So that would be h, and then here is f of a. So I do not add this one because it is not part of my integral. I want to find the integral from a up until b. No. Let's have an example. Let's say that our independent variable x is 0, 1, 2, 3, and our independent variable f of x is 10, 12, 14, 16. And I want to find the integral of f of x dx starting from 0 all the way to 3. So using the composite rectangle rule, the step here is 1. So we see that we walk on the x-axis with a step of 1. So h is 1 multiplied by the summation of f of x. Remember, we ignore point A. So this here is point A, and this here is point B, the last one, and this of course is x1, this is x2. Okay, so ignore f of A. We start from fx1. So here 12 plus 14 plus 16, and this of course equals to 42. And this is the composite rectangle method.